In this video, we'll be evaluating limits. So first we need to understand what is a limit. So a limit is the value a function approaches at a point. So the key word here is the word approaches. It's not necessarily the value at that point, but we're trying to see where the function is heading, where it's approximately going to be. So let's look at a few examples here so we can kind of see what's going on. So if we have the limit of x as it approaches 0 of cosine of x plus sine x, we can kind of see where it's going. So the first thing that we can do is we can always try to put in this value and see what we get. So for this example, we can do cosine of 0 plus sine of 0. And what we have here is cosine of 0 plus sine of 0 is just equal to 0. And cosine of 0 is going to be equal to 1. So this one's pretty straightforward. So what we see here is as this limit is approaching 0 on the x-axis, it's going to be approaching 1 on the y-axis. So kind of taking a further look here on our graphing calculator, we have the function here of cosine of x plus sine of x. So we see here as x is going towards 0 on the x-axis, our function is approaching 1. And it is defined here at 1 because we were able to solve the limit. So we see that from either direction, from the positive direction and the negative direction on the x-axis, as we get closer to 0, our function is going to go up towards 1. So pretty straightforward. So we'll look at a few more complicated ones here. So for this one we have the limit of r approaching 0 of r minus 1 cubed plus 1 divided by r. So again, we can do the same thing. We plug in 0. So we have 0 minus 1 cubed plus 1 over 0. So here's kind of the purpose of limits. We see that right here we can't really solve where it's going at 0 because at 0 we're going to be undefined because 0 cannot be in the denominator of our function. So the best way to go about this one is we can kind of see what happens if we expand our numerator here and see if we can maybe get rid of this r. So we have r minus 1, so we'll take this cubed and we'll expand it out here. So r minus 1 times r minus 1, so we have r squared minus 1r minus 1r plus 1. We have r squared minus 2r plus 1, and then times that by our last r minus 1. We have r cubed minus 1r squared minus 2r squared plus 2r plus r minus 1. So we get r cubed minus 3r squared plus 3r minus 1. So this is kind of what our numerator looks like, and so then we have to remember that we need to add this plus 1 again at the top, and we have that all over r. So as you can see here, these cancel out, and we are left with r cubed minus 3r squared plus 3r over r, and we can see we can nicely take out this r and get 3r squared minus 3r plus 3 over r. These r's cancel out, and we're left with a much nicer looking function here that we can plug, now we can plug our 0 into. So then we'll just have 0 squared minus 3 times 0 plus 3, and our y value is approaching 3 on our y-axis. So again, we can look at our graphing calculator, and we see that from the right side of our function, as we're approaching 0 on our x-axis, it's also approaching 3. and then also from the negative side we're approaching 3. But if we zoom in here, we can see that at 3, our function is going to be undefined because we can't divide by the 0. So there's that one. And then finally, we'll take a look at a more complicated one. And we'll have limit of h approaching 9, square root of h minus 9 to the 4th. So again, we can start off with putting our number in here, and what we see is we can't do that down here. We have square root of 9 over 9 minus 9 to the 4th. Well, that's just 0, and we can't have that happen. So it's undefined at 0, or at 9. But what we see here is we kind of have this more complicated situation that we don't necessarily want to have to completely factor out. So I did that by myself. I'll show you what that looks like. So we have h to the 4th minus 36h to the 3rd plus 486h squared So as you can see, this is a very complicated thing to have to try to, break down, especially if you're taking a quiz or a test. So we kind of want to avoid that. So what we can do here is we can use some more mathematical reasoning to figure out where our limit is approaching. So in this situation, we have square root of 9 over h minus 9 to the 4th. So that's going to be 3 over the square root of h minus 9 to the 4th. So since we know that we can't do 9 exactly, we can kind of see what happens if we get really close to it. So I'll kind of do like a little table here to see what's going on. So we'll have what our h value is, and then we'll kind of see what happens. So if we have, let's say, 8.99, so we're really close to 9, but we're not quite there. So our h minus 9 value would be equal to 0.01. Then our h minus 9 value to the 4th would be this really small number. So then finally you take this number and you divide that number by 3. That's kind of what we want to see, what's happening here. So in this case, for this first one, it's going to be a really big number. So as we can see, when we take a number on top of 3 and we divide it by a really small number, we get a really big number. So we can kind of see what happens when we keep going closer to 9. So we have 8.999. Well, we'd have 0.001. And then that squared is going to be, again, a really small number, 1 times 10 to the negative 12th. And then dividing that by 3, or 3 divided by this number, is going to be an even bigger number at 3 times 10 to the 12th. And then finally, we can go 4 digits out, we get 0.0001. To the 4th is going to be 1 times 10 to the negative 16th. So as we can see, the closer our number, our h value gets to 9, since we can't be exactly at 9, this number in the denominator is going to get smaller and smaller, and when you divide by a really small number like that, the number just gets bigger and bigger. So this can go on for infinity. So what does that mean? That means that since our number is getting larger, our limit is going to be positive infinity. It's going to go on forever in our y-axis, forever going up, once the closer we get towards 9. from either direction. So again, a good way to visualize this is looking at the graphing calculator. So as we see here, so it's kind of constant, and then we get to 9. We see that it goes up infinity in the y-axis. It just keeps going up. So as we can see, the more we zoom out, it just keeps continuously going up, positive in the y-axis direction. So those ones are kind of a little trickier, but you know, you can always do this little table to try to, you know, mathematically reason behind it, what's going on in the situation. So please comment below if you have any questions, and please subscribe. Thank you.